You are welcome to this lesson on trigonometry. Today we'll be looking at special angles. Our learning objectives are to identify special triangles, determine the exact value of sine 30, cos 30, and tan 30. Determine the exact value of sine 45 degrees, cos 45 degrees, and tan 45 degrees. We also determine the exact value of sine, cosine, and tangent of 60 degrees. We'll be applying our past knowledge of right angle triangles, specifically Pythagoras theorem, to new situations. Some of the key terms we're going to use in this lesson are right angle triangle, a 30-60 triangle, 45-45. Now let's look at a 30-60 triangle. A 30-60 triangle is formed from an equilateral triangle having the angles to be 60 degrees each. The bisector of one of the angles gives the angle 30. If it is assumed that the length of each side is 2 units, it therefore means the side opposite the 30 degree will be 1 unit, and the side opposite the 60 degrees can be calculated using Pythagoras theorem. 2 squared minus 1 squared gives us 3. Therefore, the length of that side will be √3. We should also not forget that a 30-60 triangle can be expressed in terms of radians. Using a conversion factor of 360 degrees being equal to 2 pi, 60 degrees would therefore be pi over 3, and 30 degrees will be pi over 6. For a 45-45 triangle, the sides are also assumed to be 1 unit. However, if you use Pythagoras theorem to get the hypotenuse, it gives us √2. The value of 45 degrees is pi over 4. Now, we can use the 30-60 triangle to find the exact value, applying our Pythagoras theorem for sine 60, which is opposite over the hypotenuse, giving us √3 over 2, while cos 60 is adjacent, which is 1 over the hypotenuse 2, that's 1 over 2, and tan 60 to be √3 over 1, which is √3. For sine of the 30 degrees, sine 30 is 1 over 2, while cos 30 will be √3 over 2, and tan 30 equal 1 over √3. We need to keep these in mind as we have to know them off heart. For a 45-45 degree triangle, sine 45 will be 1 over √2, while cos 45 is also 1 over √2, and tan 45 is 1. We also need to know the values of sine, cosine, and tangent for the different quadrants. In the first quadrant, sine, cosine, tangent, and its reciprocals are all positive. For values of theta between 0 and 90, they all have positive values. In the second quadrant, for values greater than 90 and less than 180, you obtain values there by taking 180 minus the acute angle. 180 minus the acute angle. In this quadrant, cosine and tangent are negative except for sine. In the third quadrant, to obtain the value, we have theta minus 180. Sine and cosine are negative except for tan. While in the fourth quadrant, we obtain our values by doing 360 minus the acute angle. Only cosine is positive in this quadrant. Sine and tangent are negative. So in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, sine and its reciprocal is positive. All other ratios are negative. In the third quadrant, tangent and its reciprocal is positive. All other ratios are negative. While in the fourth quadrant, cosine and its reciprocal is positive. All other ratios are negative. We can use cast to remember in which quadrant each of the three ratios are positive. Cast, C-A-S-T, C for the fourth quadrant, A first all, S sine for the second quadrant, and T tangent for the third quadrant. Now the summary of all the exact values of sine 30, 45, and 60 are displayed above, below. For cos 30, 45, and 60, while tangent 30, 45, and 60. Now using this table, we can calculate the exact value for other ratios. Now use this table to write the exact value of sine 150 degrees. 150 degrees is in the second quadrant. So we do 180 minus 150. That gives us 30 degrees. However, in the second quadrant, sine is positive. So sine 150 is going to have the same value as sine 30, which is 1 over 2. Using the same value, using the same table, what is the exact value for cosine 135 degree? Cosine 135 degree is also in the second quadrant. So 180 minus 135 gives us 45. However, cosine is negative in the second quadrant. So cosine 135 will be minus the value for cosine 45, which is minus 1 over root. Same for tan 120. 120 would give us 180 minus 120, which is 60. Tan 60 is root 3. Therefore, tan 120, which is negative in the second quadrant, will be minus root 3. Now, you pause this video and have a go at the following questions. When you are done, you allow the video to play and you can check your answers. Cos 300, cos tan 315, tan 240, sine minus 330, cos minus 30, tan minus 135, sine minus 210, and cos 315.